What's going on, everyone? This is Gaurav and welcome to my learning channel. So in today's video, we'll learn about basics of conditional probability. So we'll start off with unconditional probability followed by conditional probability. We'll try to understand the same with the help of a Venn diagram, and then we'll wrap it up with one of the interview questions. So let's get started. So if you have been following the playlist for statistics or probability, then all of the examples that we have discussed so far are the classic examples of unconditional probability. And the reason behind is that there hasn't been any additional condition provided per se. So say for instance, one of the example that we keep using is throwing a dice. Now for throwing a dice, if it is a fair dice, the probability of getting 1, 2, 3, 4, 5 or 6 remains exactly the same, which is 1 upon 6. And it really doesn't change how many times you're going to throw the dice or where are you throwing the dice. Now let's take a look at an example of conditional probability. Let's try to understand the concept of conditional probability with the help of a simple question. So the question is, calculate the probability of observing an even number for a fair dice throw. So for numerator, only 3 number qualifies, which is 2, 4, and 6. And for denominator, all the 6 faces qualifies. So the overall probability will come out to be 1 plus 1 plus 1 divided by 6, which is 1 upon 2. Now let's say if I ask you the same question, but now I provide you an additional information. So the question still remains the same, which is calculate the probability of observing an even number, but the additional information is that the number on the dice throw was less than 4. Let's again take a look at the eligibility and ineligibility criteria for each one of the individual numbers. So I've tried tabulating the same on this table. So on the left hand side, you have the number on the face of dice, and on the right hand side, you have the eligibility criteria. So as you can see that now only 3 number qualifies given the additional information, which was the number on dice throw was less than 3. So only 1, 2 and 3 qualifies, 4, 5 and 6 are not qualified anymore. They are ineligible. So given this additional information, the probability calculation will be 1 upon 3 because for numerator, only 1 number qualifies, which is 2. And for denominator, 3 number qualifies, which is 1, 2 and 3. So this is a classic example of conditional probability. Now you can also denote this with probability, which is P, A given B. The event A here is event of getting an even number, and event B here is event of getting the number which is less than 4. This way of denoting the probability is very important to understand because we'll keep on using this again and again as we move forward. Let's try to understand the concept of conditional probability with the help of a simple Venn diagram. So in this Venn diagram, the rectangle represents your overall event space, and you have two events, which is event A and event B. So we have to calculate the probability of event A happening given event B has already happened. So that will be equal to probability of A intersection B, which is this shaded area, divided by probability of B, which is this entire section. So I hope physically that also makes sense. Probability of A given B is equal to this area divided by this entire area, which is A intersection B divided by probability of B. Now, if you flip the sign, which is probability of B given A will be equal to probability of A intersection B divided by probability of A. So I hope this does give you a good idea about conditional probability. You can go ahead and use this formula to solve any kind of a question that comes when it comes to the conditional probability. So with that, let's take a look at a very simple numerical example of how to calculate the conditional probability. And you could expect a question like this to come into your interviews. The question is, in a class of 100 students, 50 students have taken science as a main subject. And of the students who have taken science as the main subject, 10 play basketball. So the question is, what is the probability of a student playing basketball given they have taken science as a main subject? So we can go ahead and use the same formula that we just learned in the previous slide, which is probability of A given B equals to probability of A intersection B divided by probability of B. Now, what are A and B? So A is students which play basketball, and B represents the students who have taken science as the main subject. So in order for us to calculate probability of A given B, we first of all need probability of A intersection B and probability of B. So let's try to calculate that. So probability of A intersection B will be equal to probability of students who have taken science and play basketball. So both at the same time. But we already know that is equal to 10. So that represents the overall number is 10. So in this case, the probability will be 10 upon 100. And probability of B will be probability of students who have taken science as the main subject. So that comes out to be 50 upon 100 because total number of students that qualify for this is 50. You have 50 students who have taken science as a main subject and total number of students is 100. So we'll plug all of these values into the formula and the overall probability comes out to be 10 upon 50. So that is 1 upon 5. So I hope this does give you a good idea about what is conditional probability, how to calculate it, and what are some of the classic examples that you could potentially expect in the interview settings. If you like contents like this, please consider liking and subscribing. That's definitely going to help me and the channel a lot. Thank you so much and have a happy learning.